Okay, hi. So good evening, everyone, and maybe good morning to some of the folks who are in different time zone. So, um, so services. Okay. So the topic today is resilient network operations and services in the COVID era and post-COVID era. So as we have seen through, the presentations by Dr. Kumar and Sarah, that post-COVID network needs to be more resilient, and so is with our services, particularly when we have to support the mission critical applications. So through the presentation, we'll see how the COVID as an impetus is changing the services evolution, tools and automation, etc. And also we'll see how the technologies are impacting the services roadmap, and how we can, most importantly, how we can address our customers' pain point around that. Okay, so COVID-19 accelerating digital journey, basically. So homes are morphing into small offices because of more work from home operations. There is a marked shift from mobile services to broadband Wi-Fi, as we had seen in other presentations, particularly in the urban areas. So interestingly, some of the statistics that have been captured, as you see on the screen, that immediately after and this data was captured around in the month of March, April 2020, just after the pandemic broke in. Okay, and within few weeks, Blue Jeans, which is the video conferencing services provided Verizon, they reported they saw a traffic surge over 50% in the first few weeks of the pandemic. Okay, since January 22, through February and March, and until March, actually it went up more than 50%. We have another data point that WebEx video conferencing services increased almost 22 times. Internet browsing went up by whopping 72%. So all these mean what? So basically, there is a huge consumption of video and data, and we need to have our networks as well as services prepared to handle this huge demand for data and bandwidth. So there is a forecast that in 2019, we had a data utilization of 1.7 zettabyte per year, and in 2024, it is expected to go up more than almost by 250% to 5.7 zettabyte per year, which is a huge jump, right? So COVID has basically catalyzed the sharp growth in the residential traffic, particularly, and home broadband. And also there is a huge increase in video consumption across the geographies. So what this is driving to, basically this is leading our basically focus with a renewed vision on operational automation. So let me start with a little bit of survey that has been done. So basically this survey was done across the industry, not just telecom, of course, and also across different service providers, ISP, CSP, bandwidth providers, and so forth, to check the readiness of SDN. Okay, so 50% of the service providers, they have reported that they have already deployed SDN in 2020, and 26% are going to deploy SDN in very soon in this year, actually 2021, and rest of them will follow the suit in 22 or in the coming years. So as you can see, there is a huge shift towards SDN. So by the way, SDN is a as you all know, it is a software-defined network. So it is a highly flexible way to adapt to the growing network requirements and to enable automation and agility. So SDN is a basically key prerequisite to drive automation and agility. So with SDN, basically, as Dr. Kumar also was pointing to in one of his topics, that it basically separates out the network control and forwarding planes. And by doing that, SDN makes network control a programmable entity and abstract the network infrastructure underneath. So basically the network control becomes programmable. That's the beauty of SDN. So, and on the right-hand side, you see how it is also driving the automation and AI and OSS, BSS solution and enhancements. So 61% they are saying that, yes, they agree, or they are using automation and AI for their applications, not just, telecom services, but also all the services application across the services supply chain, right? So we are talking about industry 2.0, right? And also what is coming hand in hand is OSS BSS automation. So COVID-19 has really accelerated the trend of, deploying advanced software tools and capabilities to enable what we call guided automation in telecom networks. So of course, we'll focus more on the telecom network. Okay, let me go to the next slide. So in this journey towards guided automation in the telecom network, there are technologies that are helping us or enabling this journey. So let's look at those elements of technology. So it has been talked about a little bit, but let me just touch upon them. Disaggregation. So disaggregation is basically an open standard architecture. So disaggregation is basically deploying the hardware and software separately that allows open architecture, right? So disaggregation is not just that. It also, disaggregation is more of a, I'd say it is more of a philosophy, right? Because it also, evolves this, our product architecture, for example, leaf and spine structure that we talked about. So these all are basically example of disaggregated architecture. So whole idea is separating out the control plane from the forwarding plane so that you can have a better centralized and more flexible control over the control of the network. Okay, and also it is leading to ORAN or VRAN and a lot of other kind of projects like OCP and TIP, which are more relevant in the IT networking. Okay. So next comes the virtualization and cloudification and orchestration, of course. So networks are shifting from basically monolithic virtualized network function running on virtual machines to more cloud native network functions running on microservices in containers. So, or accordingly, our tools and services need to also evolve to handle those new architecture, right? Virtualized and container architecture. Then the third one is that Sarath has talked about is network slicing, again driven by SDN and MEC. So SDN makes network control a programmable entity, as I already mentioned about, okay, and makes it easy to kind of manage the network or the infrastructure under that layer. Next comes the OSS BSS modernization, okay, which we are pointing to in the previous slide. So which uses different kinds of analytics, CNF. So CNF is basically cloud native function. Okay, so OSS BSS modernization using CNF, and it is using the CNF both for the development as well as operation. So that's the beauty. So we are using the cloud computing and things like that. To develop products which are zero touch, that support zero touch provisioning. We are using the same technology to kind of automate our operations in the BSS domain. For example, smart workforce management system or dynamics workforce management system. So same technology is applied in different areas. And the last piece in the jigsaw puzzle is automation and AI. That is using AI ops, ML, and today we are talking about self-healing network that can drastically reduce the need for doing the repetitive task of maintenance or the your investment in the NOC and all that, and have them focus doing more quality job like data scientist or developing the codes, leaving the day-to-day maintenance to the software. So with that, let me go to the next topic. So before I go that, 5G sits in the center of the heart, right? So all these are driven by 5G, of course, because 5G provides a platform with much higher data speed and bandwidth. So it is it can support 100 times more data speed and also 10 times better latency. That provides a platform to for all these elements to come together. But nevertheless, even in the absence of 5G, we have 4G densification, small cell densifications are happening. So it is not that without 5G, we cannot have these elements or transformations. Even on the 4G, we can have all these transformations like OSS, BSS, modernization and automation. Okay, so now let's look at it from telco or the operator's point of view. So what are the telco priorities? Basically, they are worried about day-to-day network operations like provisioning. Okay, so we are talking about automating the provisioning, okay, which again reduces the chances of man-made errors or creating the trunks in a wrong way, or having kind of hanging circuits, what we call in the SDH network. So those kind of things can be avoided with automatic provisioning tool. Network operator is also concerned about the service assurance. So while we migrate the network from 3G to 4G to 5G, we need to make sure that our quality of service is maintained. And the other thing is the intelligent analytics. So intelligent analytics sits on the top of everything, the provisioning, the assurance, the network monitoring, to provide useful data to be able to take kind of intelligent decisions about whether it could be related to network capacity monitoring, or it could be related to the bandwidth utilization, or it could be related to the utilization of your workforce, field force workforce. So intelligent analytics engine sits on the top of all these layers. And yeah, let me go back. And of course, for doing all these jobs, what we need is unified NMS, network management system. So this is a little bit of kind of a pictorial representation how the network management complexity is increasing due to growing technology diversity, right? So as Sarath was pointing out that, even by 2025, we are still going to have a significant portion of 2G network, right? So there are going to be 2G, there are going to be 3G, there are going to be SDH. On top of that, there are going to come OTN and DWDM network. Okay, so we are going to have TDM services. At the same time, we are going to have SDH over OTN. We are going to have packet over OTN, packet over DWDM, GPON over packet. So all these complexities, and we cannot imagine to have separate NMS to handle each of these technologies, right? One NMS for 2G, one for 3G, one for 4G. That's not feasible. So it is important to have a universal NMS, and I want to mention over here that Tejas NMS supports all these technologies and all these applications, and it provides a single pane control, which is emerging as a critical need for our network operators and CSPs, because it is very important to have a single pane control, because you cannot afford to have multiple monitors in front of you monitoring your OTN network, another for monitoring your SDH network. It has to be a single, on a single pane and on a single kind of a window that the NOC guys can monitor efficiently. Okay, so a little bit more on the unified NMS and basically how it is also helping in the OSS BSS automation. So you see the unified NMS, as I talked about, that it supports the cross technology and it is really vendor agnostics. So our NMS can support any other vendor's equipment, okay? And it has a centralized single pane control, and it is multi-technology. So it supports SDH, DWDM, PTN, Ethernet, OTN, all these things. And on the right-hand side, you see a actual kind of a menu from the NMS. So you can see the drop-down menu over here with different technologies or applications, and you can play around with the different topology view. For example, HO trunk view, or you want to have the OTN fiber view at the physical layer, or you want to look at the DWDM fiber view. So everything is possible with the single NMS. Okay. And another important thing, the alarm correlation. So this is very important in OSS integration, particular, or OSS automation, that we need to have a very good alarm correlation. So our NMS uses, AI ops and AI basically to provide the intelligence of different correlations. So when there is a fault in the network, the operator would be interested to see that fault is basically correlated to which service is impacted by this fault, right? Because end customer will just complain, this service A is down or service B is down. And your NMS is showing that there is a fault in a particular circuit or in a particular node. So we need to be able to correlate which fault correlates to which service. Fault to topology. So it also helps to identify the fault in a topological view. So we should be able to pinpoint really which path is affected, or which particular node is affected, or which trunk is affected. And fault to inventory. It also goes to pinpoint the fault to the inventory level, which is basically hardware inventory. So to identify which port is faulty, right, in the particular card. So NMS provides all those intelligence. Next slide, I want to talk about a little bit on this is another pain point area for the customers, as I have seen, is, a lot of bandwidth is wasted because there is no scheduling of the bandwidth. So it may so happen that, there are sometimes there are major events and you need a huge bandwidth, but for a day. Maybe there is a cricket match or something like that, or some show is going on in a particular area. So you need a lot of bandwidth in that particular geographical area. So this can be, addressed through what we call bandwidth on demand. So this is unplanned bandwidth provisioning for the events, and also we can schedule the bandwidth calendaring to take care of the scheduled kind of maintenance task like backup and all. We can schedule them in advance to be able to maximize the usage of bandwidth, to be able to maximize the optimal usage of bandwidth, and which of course improves the ROI for our customers. All right. So next slide, I want to talk about the the importance of remotization, because in the COVID scenario, there are travel restrictions and the engineers cannot always travel to whether it is within India or outside India. Okay, so the importance of remotization and importance of NOC and NMS is becoming paramount. So it is very important to have a streamlined topological view, or the alarm view. As you can see, on the top, you can see a very cluttery network. Okay, this is one of our customer networks, by the way, which we started looking at and improved them to, you can see in the below, they are now much better organized, and you can identify when there is a RAID on a particular network trunk or on a node where that fault is located. Otherwise, in a cluttery kind of a topology, it is almost impossible to identify a fault, right? And you can have many hours of downtime. So all these things can be done remotely, right? So simplified and very clean topology view is very important. And also another aspect is the NMS enables in-service SLA testing. So when a service is being delivered, which is basically through what we call the CIR, which is guaranteed information rate, right? So we can monitor the service quality of service when the service is being delivered. So we can monitor the SLA on the fly. So that is another important dimension of the our NMS, that it provides with the capability of in-band DWD and OTN health monitoring, and supports advanced forensics based on different kind of simultaneous service deliveries and SLA confirmation, which is very important for network operator. All right. So as I mentioned earlier, that network analytics that sits on the top, and it basically helps in different areas. So be it network capacity forecasting, which guarantees a higher ROI, okay, through reduced so we need to avoid over provisioning or under provisioning, right? So it is very important to have a network capacity forecasting tool, right? The operator should be able to, based on the traffic pattern or based on their business projection, they should be able to forecast what is going to be my capacity requirement and provisioning, or kind of growing the network in line, and also through dynamic provisioning of the bandwidth to allocate the bandwidth in a most cost-effective way. So that's one area. Second area is the alarm correlation we talked about, and root cause analysis. So having a clean topology view and very good alarm correlation is very important to reduce the false alarms, or what we call sometimes no alarm storms. Okay, and also it helps to prevent the issue. So not just reactive kind of fault detection. NMS can help prevent the issues by what we call predictive maintenance. So it can predict the fault. Again, with the use of AI and ML, it is possible to predict the fault. So telcos are harnessing this analytics advantage, to gain insight on their networks and the traffic patterns. And there are multiple use cases that are available that leads to the savings of, we can clearly show how it is leading to the savings on CapEx and OpEx. And by the way, this becomes an important element of our managed services portfolio. Okay, so let me converge a little bit now. So how all this is basically coming together. So if we have to, show the what is the future of services, right? Or evolution of services delivery, or the transformation of services delivery. So there are basically four, cornerstones, as you see. And there are some catchy names, but I'll explain. So first one is the connected digital worker. So those are the technicians who are, on the ground, okay, are doing the installation and commissioning, right? So they can be equipped with real-time communication, equipment. For example, QR-enabled QR code, augmented reality-enabled, what we call something like Google Glass, okay, and so that they can perform their operations in a more efficient way, okay, and they are kind of monitored or guided by a digital enablement center. So this is the centralized, what we call knowledge center, or the remote delivery center. So the remote delivery center expert who has high level of expertise can connect with the on-site technician who need not have that high level of expertise, but can simply follow the commands given by the digital enablement center through the recorded video, through augmented reality, to perform the works in a more mechanical way, okay, and most importantly, in a more fault-free way. So connected digital worker, digital enablement center. Then the third thing is next generation sourcing, which we call crowdsourcing. So when we are coming to installation of thousands and 10,000s or 100,000s of CPs, or we are now ONTs are coming in the home, right? So we need to have a different kind of vendor ecosystem. So to be able to do this kind of deployment, large scale deployment, what helps, which is not very popular yet in India, but in other countries, is crowdsourcing. Of course, crowdsourcing is there in India, but more in the IT domain. But the same concept can be used, or the same ecosystem can be developed in India as well for telecom and hardware installations. And of course, it needs to be powered. I mean, just crowdsourcing will not work because crowdsourcing technicians will be very minimally qualified, engineers or technicians. So they need to be aided by this connected digital worker and digital enablement centers, okay, to be able to, for them to be able to perform efficiently. And of course, the analytics and artificial intelligence aided by big data or AI/ML across the entire network infrastructure, that sits on the top, as I said. So ultimately, these four cornerstones, they come together in our services delivery roadmap, which ensures improved speed, quality, and efficiency of network services, right first time, okay, and real-time operations, real-time automations. Okay, so this is, I think, my last to last slide. So here we are talking about managed services. So managed services, you all are familiar. So here, Tejas works as the one-stop shop or central point of contact for our customer to manage their complete network end-to-end. So when you say managing the network, it includes management of the NOC, it includes installation commissioning, it includes FLM, field level maintenance, it includes regular maintenance, O&M of the network, it includes fault management, it includes performance management, it includes traffic monitoring. Sometimes it may include engineering as well, so that our customers don't have to worry about operations. So anything and everything related to operation, they can offload to Tejas, focusing on the business and revenue. So managed services, our managed services model really focuses on enhancing and customer experience through QoS. So when you say customer experience, it is not just our direct customer experience, it is customer of customer, so end customer experience, okay, by putting in place a very strong governance and interlock with customer organization at various levels. So this pyramid that you see on the left, so that shows the interlock between Tejas and with customer at different level. So starting with the lowest level, which is the operations level, so basically monitoring day-to-day operations, etc. Then also the next level, program management and KPI monitoring. So that is the next level. Also, it looks into, what is the overall assessment of the health of the network. Is the managed services journey going in the right direction? Are the KPIs really improving from the baseline KPIs? Are there cost savings, which is another important element in managed services? Are there OPEX savings really happening? So it really monitors all that thing. And there is a executive level management, interlock as well for all managed services contracts. So who talk to them regularly through governance calls to make sure that we are on right track, okay? And most importantly, as I was saying, that the managed services is powered by all these tools and automations and, what we call the predictive maintenance to improve the uptime of the network, and also to avoid the outages and faults in the network, and also improve the ROI of the network by managing the network better. So with that, my last slide. So here I tried to capture so how do I describe the future of services? So future of services is really more resilient, right? And you can see that it is really, oh, I'm sorry. So it has to be resilient. It has to be remotized, okay, with the zero touch provisioning and all these things, okay. And we are slowly moving towards what we call, everything as services. So we talked about SaaS in the earlier years, right? Then we talked about enterprise as services. Then we talked about infrastructure as services. So now we are coming to a stage where everything, including even the equipment, can be offered as services. A platform can be offered as services. So with that, what is happening? The line between the product and services is really becoming very thin. Okay, so that's the direction of the future services, and of course this is required to support the the recent trends and the post-COVID trends, particularly the work from home we talked about, healthcare. Okay, there are more and more use of telemedicines, okay, remote consulting and all those things. So there is a need for very high speed connectivity to the hospitals. E-education, study at home. Most of the exams are happening online, as you know, as we have seen. So it has to be a very secure broadband, connection. Okay, with of course sufficient redundancies. It needs to support the lot of video sharing and all that. And also we are talking about automated manufacturing industry, 2.0, accelerated adoption of IoTs, AI and VR and all that thing. Over the top entertainment, video streaming and video calling, they are like, going up like by leaps and bounds. Okay, cloud gaming is becoming more popular day by day. Digital economy, e-economy, that was already there, but that is becoming even more important today. So all these services needs to be supported, and for that we need to transform the services, okay, along with our product development or the technology development. And of course, with the advent of 5G, this is going to be even more disruptive. That will impact our society and economy as a whole. Thank you. I think that's the end of my presentation.